Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 69, for broadcast on the 9th of June 2023. Coming up on SpaceTime, creating life on Earth, training for the first Mars sample return mission, and Virgin Galactic now in countdown to its first commercial launch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have proposed a new scenario for the emergence of the first building blocks of life on Earth some 4 billion years ago. The research, published in the journal Science Reports, show how iron particles from meteors and volcanic ash could have not only served as catalysts for converting a carbon dioxide-rich early atmosphere into hydrocarbons, but also acetaldehyde and formaldehyde, which in turn serve as building blocks for fatty acids, nucleic bases, sugars, and amino acids. To the best of our current knowledge, life on Earth first emerged just 400 million to 700 million years after the planet itself was formed 4.6 billion years ago. Now, that's a fairly quick development. Now, for comparison, consider that afterwards it took about 2 billion years for the first proper eukaryotic cells to form, that is, cells with internal structures. The first step towards the emergence of life is the formation of organic molecules that can serve as building blocks for organisms. Now, considering how fast life itself arose, it would be feasible for this comparatively simple step to have been completed quickly as well. The new research provided in this study presents a new way for such organic compounds to form on planetary scales under the conditions prevalent on the early Earth. Now, the key supporting role goes to iron particles produced from meteorites, which would act as a catalyst. Catalysts are substances whose presence speeds up specific chemical reactions, but do not get used up during those reactions. It's sort of like using tools in the manufacturing sector. Tools are necessary to produce something, like, say, a car. But once the car's built, you don't need those tools for the car anymore, and instead they can be used to build the next car. Key inspiration for this new research came from, of all things, industrial chemistry. Specifically, Oliver Trapp from the Ludwig Maximilians University in Munich and the Max Planck Institute for Astronomy wondered whether the process for converting carbon monoxide and hydrogen into hydrocarbons in the presence of metallic catalysts might also have been an analogue on the early Earth with a carbon dioxide-rich atmosphere. Trapp says that when he was looking at the composition of the Campo del Celio iron meteorite, which consists of iron, nickel, some cobalt and tiny amounts of iridium, he realized that this looked like a perfect catalyst. So the next logical step was to set up an experiment to test the cosmic conversion of the catalyst. Now, as well as studying iron meteorites, Trapp and colleagues also looked at the catalytic properties of volcanic ash particles. After all, the early Earth should have been full of lots of geological activity, and so there should have been plenty of fine ash particles in the atmosphere and on Earth's first land masses. The first ingredient for the experiment was always a source of iron particles. Now, in different versions of the experiment, those iron particles could be iron from an actual iron meteorite, or particles from an iron-containing stone meteorite, or volcanic ash from Mount Etna. The latter is a stand-in for iron-rich particles that could be present in the early-day Earth with its highly active volcanism. Next, the iron particles were mixed with different minerals of the sort that might be found on the early Earth, and these minerals would act as a supporting structure. Now, the fine volcanic ash particles produced by volcanic eruptions are typically just a few micrometers in size. Now, for meteorites falling through the atmosphere of the early Earth, atmospheric friction would ablate nanometer-sized iron particles, and the surface impact of an iron meteorite or iron core of a larger asteroid would produce micrometer-sized iron particles directly through fragmentation and nanometer-sized particles as iron evaporated in the intense heat and later on condensed again in the surrounding air. Now, since Earth's initial atmosphere didn't contain oxygen, the authors then followed up with chemical reactions that removed almost all the oxygen from the mixture. And as a last step in each version of the experiment, the mixture was brought into a pressure chamber and filled with mostly carbon dioxide as well as some hydrogen molecules in order to simulate what the atmosphere of the early Earth would have been like. Now, both the exact mixture and the pressure were varied between experiments, and the results were impressive. Thanks to the iron catalyst, organic compounds such as methanol, ethanol, and acetaldehyde were produced, and also formaldehyde. And that's an encouraging harvest. Acetaldehyde and formaldehyde in particular are important building blocks for fatty acids, for nucleobases, themselves building blocks of DNA, for sugars, and for amino acids. Importantly, these reactions all took place successfully under a variety of different pressure and temperature conditions. So with these new results, it means there are now new contenders for how the first building blocks of life could have formed on Earth. And that allows them to join the classic mechanisms, such as organic chemosynthesis near hot vents on the ocean floor and electrical discharge through lightning in a methane-rich atmosphere. This is SpaceTime. Still to come, training for the first Mars sample return mission. And Virgin Galactic now in countdown to its first commercial launch. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Missions to Mars have made many exciting discoveries that have transformed our understanding of the red planet. Orbiters, landers and rovers have studied the Martian surface in great detail, finding a freeze-dried desert that billions of years ago would have been a warm, wet, habitable world capable of supporting life. But all these studies were forced to use compact equipment and instruments that limit the amount of science that can be achieved on any given mission. Clearly, the next step is to bring these samples from Mars back to Earth for more detailed analysis in more sophisticated laboratories. There, Martian rocks can be analysed by the most technologically advanced equipment, allowing scientists to verify different results independently. In addition, as equipment improves and new advances are made, samples can be reanalysed and new information extracted. In fact, that's happening right now with lunar samples brought back to Earth in the 1960s and 70s by the Apollo astronauts. So, bringing samples back from Mars on a robotic mission is the next logical step. But it's not going to be easy. In fact, it will require multiple missions. It'll be more challenging and more advanced than any robotic mission ever done before. But at the same time, it'll also be an incredible precursor to future manned missions to the red planet. And right now, they're only about another 10 or so years away. Already, the European Space Agency and NASA are working to explore mission concepts for an international Mars sample return campaign slated for the late 2020s. The first part of this project's already underway, with NASA's car-sized six-wheeled Mars Perseverance Rover and its Ingenuity helicopter exploring Jezero Crater and collecting samples for eventual return to Earth. Jezero Crater was chosen because it includes a giant river delta, a place where sediment from further upstream can be collected, and the sort of environment which would have harboured life had any ever existed on Mars. Now, half the samples being collected by the Mars Perseverance Rover are stored in a special cache deep inside the machine. The rest, the so-called backups, have now been carefully placed in a depository on the Martian surface. There, the sample tubes were imaged from different angles and their exact location recorded. But collecting samples is one thing. Getting them back to Earth is quite another. To achieve that feat, at least 2 more Earth-to-Mars flights will be needed. One will place an Earth return orbiter spacecraft into Mars orbit, and the other will send a lander to the red planet, which will touch down close to Perseverance. The lander will carry its own helicopters and rovers in order to gather the samples collected by Perseverance. It will then collect them and load them into a Mars Ascent Vehicle, basically a small rocket also mounted on the lander. Once loaded, the Mars Ascent Vehicle will launch back into space, performing what will be the first liftoff from Mars, and then rendezvousing and docking with the prepositioned Earth return orbiter. The samples will be sealed in a special biocontainment system in order to prevent contaminating the Earth with unsterilized material. The samples will then be transferred into an Earth entry capsule, which is mounted aboard the Earth return orbiter for the flight back to Earth. As the Earth return orbiter approaches Earth, the Earth entry capsule will be jettisoned, and with it, the precious samples. Capsule will parachute down to the ground, from where the samples will be transported to a special handling facility. And it's only in there that scientists will be able to begin the real work of studying the Martian samples. An important part of the mission will be the detect, fetch and collect phase on the Martian surface. Now, it all sounds easy, but remember this will be happening 290,000 million kilometres away, with its time delays and radiation interference, where anything that can go wrong will go wrong. Testing the technologies for the mission is Laura Beilenberg, an ESA scientist with the Mars Sample Return Campaign. Her work takes place on a rock-strewn recreation of the red planet at ESA's Mars Yard in the Netherlands. The sample tubes being collected here are exact replicas of the sample caches that NASA's Mars Perseverance Rover is leaving on the red planet. They're called RESTA, an acronym for Returnable Sample Tube Assembly, but to most Earthlings, they look more like lightsabers. Bielenberg's investigating different sample tube collection strategies to see what works best. For example, the sample transfer arm on the rovers will need to collect the tubes on the Martian surface, transport them back to the Mars Ascent Vehicle, and then place them inside the rocket. Those that can't be collected by the fetch rovers will be collected by the helicopters using grappling hooks and cameras. It's a complicated and difficult mission. This report from ESA TV.
This testbed is all about finding samples on Mars, detecting them, estimating the pose, bringing them back to Earth to then be analyzed by scientists and figure out what Mars is made of. These kind of tubes are already on board of Perseverance on Mars, and Perseverance is using them to collect samples of the Martian surface and of regolith, and it's stored inside the tube. Well, it looks a bit like a lightsaber, doesn't it, if you look at it? So you could imagine just going like this and being a lightsaber, but it's much cooler than that because it has actual Mars soil in it. Europe, ESA and NASA are collaborating on this, so together we have this Mars Sample Return Campaign in which we return the samples from Mars, and Europe is playing its part by having still the sample transfer arm, which is going to collect the samples from Perseverance and also samples that are dropped by the Mars helicopters and put them in the orbital sample to be flown back to Earth. And that would be the first time in human history to actually bring back samples from Mars. This is the Planetary Robotics lab. We have a beautiful Mars yard, and this is where we test our rover prototype. So it takes an image from above with the NAVCAM on the top, and then in a second step identify some key points in this tube image to get the pose estimate of the tube. You can never really recreate 100% the outdoor lighting environment, but we try to have a mixture of direct lighting with our Fresnel lens with an LED, and also some environmental indirect lighting with our lab lights. And also to make it look more Mars-like, we're using the Mars lab here that we have, where we have different types of terrain. So we have sand, we have big stones, we have pebbles, we have flagstones. It's pretty amazing to think that you could contribute to finding out something about another planet in our solar system, and to actually work on a robotic system or on the research that leads to a robotic system that actually flies to Mars in the end. That is pretty amazing.
This is SpaceTime. Still to come, Virgin Galactic now in countdown to its first commercial launch. All that and more still to come on SpaceTime. Virgin Galactic has successfully carried out its first suborbital flight in nearly 2 years and is now set to begin commercial space tourism operations within weeks. The mission aboard VSS Unity from Virgin Galactic Spaceport America complex in New Mexico followed a series of safety upgrades to Virgin's growing fleet of winged rocket planes. You see, its previous flight in 2021 sparked an official Federal Aviation Administration safety probe after the spaceplane dropped below its assigned airspace descent rate during the glide back to the planet's surface. The FAA cleared the company to resume flight only after safety modifications were carried out designed to keep the aircraft inside its flight envelope. The Unity 25 mission flew 4 Virgin Galactic employees to an altitude of just over 87 kilometres on what's considered the final shakedown test flight. The next flight, the first for paying passengers, will carry members of the Italian Air Force. Unlike its main competitors in the space tourism race, SpaceX and Blue Origin, who both launch their rockets vertically, Virgin Galactic launches its winged spaceplanes, known as Spaceship Twos, from between the twin fuselage assemblies of a custom-built 4-engine jet aircraft mothership known as White Knight 2. It has the advantage of being able to take off horizontally from a conventional runway. Then, after climbing to around 50,000 feet, the Spaceship 2 rocket plane is released in what's called a drop launch, quickly firing up its hybrid rocket engine and accelerating to around Mach 3 as it climbs vertically on a ballistic trajectory that takes it just below the 328,000 feet or 100 kilometre high Kármán line, the internationally recognized official start of space. After a few minutes of weightlessness with the world's best views, taking in the blackness of space, curvature of the Earth, and the thin blue line marking the planet's life-giving atmosphere, gravity starts to bring the journey back towards the ground. The spacecraft eventually gliding to a conventional runway landing roughly 90 minutes after launch. It's taken a long time to get here, and it hasn't been without its problems. Virgin Galactic space program suffered years of delays, and there was that fatal 2014 accident due to pilot error. But it hasn't stopped enthusiastic space tourists wanting to go for a ride. Virgin says it's sold around 800 tickets so far. While initially selling for around $250,000 a seat, those tickets are now going for an eye-watering $500,000 each. But when you think about it, that's a bargain compared to SpaceX, whose Axiom 2 space tourism passengers paid around $80 million each for their 10-day trip to the International Space Station. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown how the COVID-19 pandemic has changed our drinking habits. A report in the journal Drug and Alcohol Review has found that adult men, those aged over 35, were most likely to increase their alcohol consumption during the early stages of the COVID-19 pandemic. The numbers are based on survey data on alcohol consumption across the UK, New Zealand and Australia. The authors of the study catalogued people into certain groups. Those who drank alone made up around 32.3% of the total. Those who mostly drank in their household, 36%. Those who drank alone and in their household, 17.9%. Those who drank mostly at parties, 3.2%. And those who drank everywhere, 1.1%. The authors say those who mostly drank alone reported the highest levels of alcohol consumption, while more social drinkers, young people and women, were likely to reduce their alcohol consumption in the early 2020s. A new study says the bacteria that caused the plague may have arrived in Britain much earlier than the Middle Ages. A report in the journal Nature Communications found 3 Yersinia pestis samples in people buried in the British Early Bronze Age around 4,000 years ago. Of the 3 plague genomes, 2 came from an unusual mass burial site and 1 from a single burial under a ring cairn monument. The detection of these genomes represents the oldest evidence of the Black Death in Britain to date. The researchers say the genomes do not include a specific gene that has been associated with the flea-borne bubonic plague of the Middle Ages, so they think this older strain may not have been transmitted by fleas. Bubonic plague killed between 75 and 200 million people between 1346 and 1353. However, plague has also been identified previously in Eurasia between 5,000 and 2,500 years ago, and the researchers say that the wide geographic spread suggests that this strain of the plague is still easily transmitted. Globally, around 600 cases of plague are still reported each year, and despite treatment, the risk of death is 10%, but that goes up to 70% if you don't have treatment. A new study shows that Australia's wild dingo populations have far fewer domestic dog genes than previously thought. The findings, reported in the journal Molecular Ecology, show that most dingo populations are purebreds rather than hybrids. The new research challenges the view that purebred dingoes were on the decline due to crossbreeding. The new findings suggest that previous studies significantly overestimated the prevalence of dingo-dog mixes. Well, if you've been enjoying the latest sci-fi zombie series, The Last of Us, you may be more than a little disturbed to learn that it's based more on science than you're probably comfortable with. As Tim Mendham from Australian Skeptics points out, there really are fungal threats out there that can pose deadly, even zombie-like control over animals.
Yes, there's fungal infections that can create very, very bad effects, and this has been known for ages. It's obviously nothing new, especially when you talk about mouldy bread or anything like that. Contaminated rye is a big thing, and there's a disease called St. Anthony's fire, which is about rye contaminated by fungi, and you get it in silos or you get it in storage or various places. You make bread out of it or whatever you make out of it, and that can lead to reduced blood flow, tissue necrosis, which is pretty horrible, central nervous system overstimulated, changes of mental state, hallucinations, depression, delirium, suicidal thoughts, intense pain, gangrene, and loss of limbs, which is the necrosis. So the fungal can be a pretty serious thing. It's not just a bit of green stuff on your toast you scrape off. The TV series is about spreading zombieism via fungus, which is probably unlikely. But the thing is, it is based on a real fungus which has a real effect, which is something called Ophiocordyceps unilateralis. How's that? I wrote it down. Or more easily, cordyceps, which is easy to say, which affects ants. And what happens is that this fungi gets into an ant somehow, and it starts to eat away at the ant until basically it consumes the whole nervous system of the ant. Causes the ant to climb up a plant, hang around on little shoots or branches or whatever, about 25 centimetres above the ground. And when the fungus has had its way with the ant, it then just drops. The fungus just spreads and drops down. It's like a little sort of shower thing up the top, and drops down fungus onto the ground beneath, and hopefully there's more ants down there and continues the cycle, etc. That's what the people who wrote the original game, The Last of Us, based it on, knowing full well it's about ants, but they applied it and extended it into sort of the Good Zombies TV show. But the fungus does do these things. Not necessarily zombifying, but it can have a very, very bad effect, and what this show is based on a prediction made in the 60s that viruses are not going to be the big problem. Fungi will be the big problem. So there's a little bit of science in there. There's a lot more fiction and scary stuff and zombies, but basically there are fungi that do horrible things to animals, not necessarily mammals. There's a case of a fungi that attacks cicadas. It deploys a hallucinogenic compound that makes the insects fly wildly. Yeah, surprised me. They're on dope, and they release spores in every direction. It's like a little crop duster. But that's only after the fungi has literally eaten the insect's genitals and bottom. So that's a good way to get the fungi out of the body. And then the male cicadas do their little mating dance, they sing, etc., to attract females, and they spread the fungus that way. Not that they can do much once their genitals and bottom have been eaten, but they can sort of attract a female and that can spread it. I mean, obviously there's wonders of evolution, the way they work, but it's a strange thing. It's a scary thing, actually.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.